Hi, I'm Norm Smith of RF Savvy Technologies, a local RF microwave design and consulting company in Northern California. And today I'm going to be demonstrating to you a product from another local company called Berkeley Nucleonics. It's a high-frequency synthesizer with options to go up to 20 gigahertz in a very portable form factor. And so I'll be getting it set up in the lab here shortly and demonstrating the product to you. Just a quick look-see at it here right now. This synthesizer is very lightweight. It weighs about 6 pounds, and that is about a quarter of the weight of the nearest competitor. It can run, because of its low power, which is about 14 watts, so that's about 7% of the power that's taken by the nearest competitor. When I say competitor, I'm talking about the big box providers like an Agilent or a Rohde & Schwarz box. And so very competitive in terms of the standard RF performance that you'd expect from a synthesizer or high frequency signal generator, but at a fraction of the cost. And so you can basically get two of these boxes for the price of one of the big box vendors. And so this runs off a 6-volt supply, but also an internal battery. It's programmable via Skippy commands. It also takes GPIB, USB or a LAN connection on the back. It is provided with low-charge GUI software that comes with every single one of these. And I'm going to be demonstrating this in the lab here shortly as a standalone demo, as well as with the remote command software that's provided with it. So again, Berkeley Nucleonics, they've been around for a long time, surprisingly, and you can download the specification and the details on the product here on their website, berkeleynucleonics.com. Well, hello again. Here I am now in the lab with the Berkeley Nucleonics signal generator, the microwave signal generator. This is actually the 845 model. It's the 845 model that we're going to be looking at today. Going to be setting this up in the lab here shortly. You'll notice that, as I mentioned earlier, it's very lightweight, 6 pounds, low power, 15 watts. With that low power, it's not generating any heat really, and so there's no need for any ventilation on the box. So there's no ventilation holes, making it great for a field application. We don't have to worry about water or dust getting inside of it. And even on the rear panel, where you might expect to see a ventilation fan, there's no fan. That makes it super quiet as well. So lightweight, portable, a very robust unit, and very easy to manage. So whilst we're looking at the rear panel here, you will notice that there are connections for an external power supply. It will also run off an internal power supply, its own internal power supply, which is an option on the box. It's got remote connections for both USB and LAN as standard, and an option for the GPIB bus if you need that. It also, in addition to putting out the microwave source signal up to 20 gigahertz on the front panel, has a function generator output as well. So there's a function output on the rear panel as well. It's an added bonus for this box. So I'm going to go ahead now and connect this up. And again, because it's also designed for lab as well as field use, the connector for the power supply is a ruggedized connector. You pop it in and give it a quarter turn so it can't be tugged out. So that makes it great for use in a vehicle or those type of applications where you don't want to risk the power supply popping out and then losing your signal. So there you go, and there's a simple on-off switch on the rear panel here. So that's going to power up, cycle through a startup routine, which takes about 45 seconds. Whilst that's starting up, you'll see that this will go immediately into CW mode on the front panel. Whilst it's starting up, I'm going to hook up the RF cable to my trusty spectrum analyzer here, which I'll be using to look at the signal in the frequency domain that's generated by the Berkeley Nucleonics product. And I'm going to switch on the spectrum analyzer right now, and all of a sudden you're going to start to hear that cycle, and the fan, which we're so used to hearing in the test and measurement world, popping on here, so that will start to create some noise. So there we go, this is just cycled, it's defaulted to 100 megahertz CW. So I'm going to go ahead and set this up to a CW frequency of 1 gigahertz, and I don't want to sterilize myself, as we say in the microwave world here, so I'm going to crank the power right down to -30. And there is a step attenuator option available also on this box, by the way. So so that's the CW settings. Now if I hit the menu button and cycle down through sweep, modulation, there's also a reference and trigger settings. I'm going to go to modulation and get the cursor lined up there on modulation, go into that menu, come down to frequency, so frequency modulation. Right now the modulation is switched off, is set for external. I'm going to bring it to internal, because you can also use an external modulation source and use the internal frequency reference, the internal source for the modulating frequency. It also has a built-in OCXO, by the way, for frequency reference, and it can take an external frequency reference up to 200 megahertz as well on the rear panel. So I'm going to go ahead and set this up. I'm going to go with 5 kilohertz for the deviation, and let's just crank this up to a rate of 100 kilohertz here, and we can see this come up on the spectrum analyzer shortly. So there we go, 100 kilohertz, my modulation rate. Switch that on, and the internal source is on now for the modulation, and then switch on the RF there. So now we're at a 1 gigahertz modulating with some FM. Now if I come to my spectrum analyzer here, set that up for 1 gigahertz. Here we go. So the marker is showing here. I'm pretty much at a gigahertz here on the marker of the spectrum analyzer. And if we look at the deviation, delta marker, you can see here the next peak is occurring at pretty much 100 kilohertz. There we go, and 30 dB down. So this is showing the modulation on the carrier. If I turn the modulation off and go back into frequency modulation and switch it off, you can see the modulation's off and the modulation's on. Likewise, I can come back out to the main menu and switch the main carrier on and off. There's the carrier on, carrier off. So there we go, that's a manual control of the front panel, just looking at FM there as an example. This box is also capable of putting out pulses that are be used in radar applications and defense applications, and chirps and more complicated signals, so AM and FM and various other modulation schemes and combinations of those can be used to modulate the carrier. Okay everyone, so I'm back in the lab, ready to re-demonstrate to you the 845 series microwave signal generator from Berkeley Nucleonics. This time I'm going to be demonstrating it used in remote access mode using a LAN connection. Now, as I mentioned earlier, it can be used with a GPIB port if you have the option on the box, or also USB. In this case I'm going to be using a LAN connection and connecting it to the laptop. So I turn this guy around. On the rear panel there is a socket, and I'm going to show you a close-up of that in a second here on the video. And I'm going to plug in the LAN cable to the LAN port, and then the other end of the cable, of the Ethernet cable, I'm going to plug into the laptop. And again, you'll see a close-up of this in a second in the video. We'll cut in, and you can see that this is already starting to communicate here, the orange and the green light on the back of that Ethernet port there for the LAN, showing me that it is already talking to the laptop. So now I'm going to go ahead and open up the software which I've earlier downloaded from Berkeley Nucleonics website at berkeleynucleonics.com, and open up the signal generator GUI. Actually version 2.68 is the current version, and I click scan instruments. Again, you can see a close-up of this again on the video shortly, and it scans it and comes up with a list of devices that it's found on the network. So here it is, the Model 845. That corresponds to the serial number here. Just notice that the remote access light just came on, the green light. So that means these two are talking. Now I can switch to the CW mode here and program this to the frequency that I want to put out for the spectrum analyzer to pick up the signal. Right now I have that set to 1 gigahertz, and I've got the power cranked down to -30. Let's move this up to -20, just so you can see that change on the screen. In fact, that's already changed on the screen. So -20 and -30, you can see it moving there. So that's with the signal on, sorry, the modulation on, but the signal is off right now. So we go to the modulation. I previously set this up for FM. Gives me a choice of pulse, AM, FM, phase modulation, chirp, a couple of other modes there as well. And so I'm going to use the internal modulation source here and set it up for FM. I think previously on the manual demo I did it based on 100 kilohertz modulation frequency. This time I'll go to 200 kilohertz and leave the deviation, maybe with deviation up from 5 kilohertz to 10 kilohertz. So now I can choose to switch on or off the modulation here, and that will switch it on and off here, and it shows me the LAN IP address, in fact, that's communicating with the source. So I switch the modulation on, and I can switch the RF on and off from here as well remotely, and there you go, the green light's coming on, and here is the signal. So you've got the 1 gigahertz carrier, and these are the spurs associated with the 200 kilohertz. Okay, it's a 1 megahertz span, and that's 2 divisions, so it's 200 kilohertz. So again, if I move this here down at 100 kilohertz, you see the modulation moving, the sidebands, spurs rather. There's 200 kilohertz, there's 300 kilohertz, 400 kilohertz as I play with the modulation frequency. Likewise with deviation, if I play with the deviation, to increase the deviation, these spurs come up, and I can actually keep increasing it to bring up another set of spurs either side. So you can see the effect that the deviation has. This is an FM on the carrier. Okay, I can switch the modulation off and the spurs go away. Switch it on, it's back on. Or switch the RF, modulated RF off. So that's a very simple way of communicating. This software allows for remote control, remote access, if you will, of the source. It can also accept skipping commands and obviously run in an ATE rack in a production environment. It's been designed to have really excellent phase noise, so it can quite easily replace most large big box synthesizers for a fraction of the cost in a production line where cost is key. And so again, this portable device is quite at home in a rack mount application or a benchtop application as it is out in the field. So I think that concludes the demo right now. We'll give you a few close-up screenshots and summarize the features and benefits and applications of the product here for you shortly on the screen. And again, I'm Norm Smith from RF Savvy Technologies. I'm an independent RF design consultant, and basically showcasing here the Berkeley Nucleonics 20 gigahertz synthesizer signal generator. Alright, so I appreciate your time today, and thanks for watching the video. Well guys, before I forget, one thing to add to the demo video here today is in addition to the 845 series synthesizer that I just demonstrated for you, Berkeley Nucleonics have also got an even lighter weight 2-pound box here. This is their 845M series. It's a modular series which I believe they even consider OEM rebranding for companies that want to integrate this as a module within a larger system or subsystem that you're putting together. But at any rate, it does just the same as the box I just demonstrated on this video. It only weighs 2 pounds and 10 watts. Very low power, again running off 6 volts. It's got the same capability for a USB or a LAN remote connection on the back, and very minimalistic on the front panel here. So obviously this is intended to be used primarily with the GUI that I just demonstrated for you as well today. So again, very lightweight, weighs a couple of pounds, still a very robust and solid box from Berkeley Nucleonics here, and only 10 watts of power. Alright, thanks again for watching.